So today we're just going to introduce slope fields, kind of go over how to sketch them. We are still going to look at slope fields tomorrow and even a little bit on Thursday. So it's not like a one-day thing. So you got some time to figure it out. Alrighty, so let's talk about what a slope field is. Differential equations are equations that involve x and y and the derivative, which is represented with y prime or dy dx, or even like f or f prime or anything like that. And so what we did is we integrated our derivative to go back and get the general solution. And the general solution has a plus c. And so we don't actually know the specific solution of it. We know the general form, and then whatever the constant would be. The plus c is representing the constant. So how that relates to slope fields is the slope field is going to represent the family of functions of the differential. So it kind of represents the general solution. So if you think about it, just as a very basic example, these are all of the possible general forms. You could have the general form, this is the shape of a quadratic, which we're going to talk about here in a second, plus c. We don't know what plus c is, but you could have a quadratic right here at 3, with your plus c being 3, because it got shifted up 3. You could have it right here at 2.5. You could have it right here at 2. Do you see how that slope field kind of makes the shape? Yeah. Right, but we don't know what plus c is, so we don't know if it's going up. It could go down. Your plus c could be -1. It could be x squared minus 1, which would be this guy right here. What is happening out there? So the slope field is like all the general forms. It's kind of the shape of the general forms. Does that make sense? So the slope field is going to represent the general form, and then if you wanted to find the particular solution, you need to be given some sort of initial condition. So you can find C. So the particular solution is when you're given some kind of initial condition, you plug that in, you find C, like you did on the homework quiz. All right, so below is a slope field. It is the slope field for this differential right here. So the derivative creates the slope field. You use the derivative to create these tick marks. And yes, you do have to actually create a slope field, not one this involved, like a more basic one. But what you're going to do to create the slope field is you're going to plug in values. So on this one, we just have x. So when x is 0, like how, all right, so if I were to do the derivative when x is 0, what's 2 times 0? 0. So do you see how at 0, all of your little tick marks have a slope of 0? Okay, well what if you're doing your derivative when x is 1? What's 2 times 1? 2. So look at, oh, why did it erase all my? So those are all 0. So look at, oh, that's not at 1. Look at 1. So do you see how at 1 all your slopes are kind of like a positive? Well, we know it's at 2 because that's what we found. All right, well, what if we did negative? So let's say we plugged in -2. So what's 2 times -2? -4. So at -2, do you see how all your slopes are negative and they're a little bit steeper than the slopes at 1? Do you see what I'm saying? The tick marks here? Those are kind of... And then these tick marks here are like positive and they're not quite as steep. Okay, so the derivative creates the slope field. Derivative creates the slope field. The slope field is a representation of the solution, the general form. And so looking at this slope field, I can look at this slope field and say, oh, it looks like a quadratic. Because your general form is going to be x squared plus c. If you were to integrate 2x, what would you get?
X squared plus c.
X squared plus c. So the slope field creates a graph of the general solution. So the slope field looks like y equals, but it's created from y prime. Does that make sense? Is that kind of okay? All right. Now there's 2 basic rules for slope fields on the AP test. Don't contradict yourself with your slopes, and we're going to talk about that when we draw it. And don't cross your lines when sketching a solution, which we will also talk about when we sketch the solutions. But those are basically your 2 main rules for slope fields. If you don't do those 2 things, you're going to be good to go. All right. So let's practice sketching a solution. All right, first of all, I'm looking here and I'm seeing that my derivative is just x. My derivative does not have y in it. So only x will determine my slope. The y does not matter. So when x see, I'm going to start with -2. All right, so we don't care about y's because y is not going to matter. When x is -2, what is my slope going to be? -1/2. So on my slope field right here, on all the -2's for the x's, I'm going to do a -1/2. Kind of like this. I don't know. You're kind of shallow, kind of negative. Now you're sketching this, so is it going to be completely perfect? No. All right, so now I'm going to do the next one. So my next one, when x is -1, what is my slope when x is -1? -1. All right, so it's got to be a little bit steeper, still negative. All right, what about when x is 0? Doesn't exist. It's undefined. So you have 2 options when it doesn't exist. You can either just leave it off, or you can draw a vertical line. Because technically, the slope of a vertical line does not exist. I personally like drawing the vertical line because I feel like you can kind of see the flow better of your slope field, but you can leave it off too. All right, and then we've got when x is 1, what is your slope? 1. So we're going to have... And then what about when x is 2? 1/2. So it's going to be positive, not quite as steep. And then this would be your slope field. So what they're going to look for on the AP test is they're going to look for the obvious things. Like at 0, you should have either a straight up and down line or no line at all. So they're going to look for undefined, they're going to look for 0, they're going to look for positives and negatives. Everything over here should be positive, everything over here should be negative, and then they're going to look for contradictions. So what I mean is these guys should be steeper than these guys because this is 1/2, this is 1. So if you draw slopes where this is more shallow and this one is like this, that's where you would lose points. But they're not going to look and they're not going to be like, well, these look almost the same thing, we're going to count off. Because it's impossible to get your slope field perfect, especially if you're drawing it by hand. Does that make sense? So they're going to look for obvious contradictions. They're not going to be so particular and be like, well, this isn't exactly accurate because you don't have a ruler or anything like that. So obvious contradictions is what they're going to look for. Positive, negative, zeros, undefined. Those are going to be the main things. Okay, so let's look at 11. So 11 uses x and y. So you kind of have to look for different patterns. Right? Because you're not going to have that simple like horizontal pattern or that simple vertical pattern, because x and y will both affect your slope. All right, so what I like to think about when I do my slope fields is I first think about when your slope's going to be 0. Because that's going to be a very obvious horizontal line. And my slope is going to be 0 when x and y are the exact same number, but different signs. So on my graph, that's going to be here, 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 and here. Exact same number, one's positive, one's negative. So this one here, 1 and -1, 2 and -2, same thing, same thing. So those will all give you a slope of 0. I also consider when your slope is undefined. Now, will your slope ever be undefined? No, because we've got x and we've got y, and so we're gonna be good to go. All right, so then I'm just gonna start working through this. So we're just adding up x and y. So at this point, it's 1, 0. So what is 1 plus 0? 1. So the slope here is 1, positive. At this point right here, 2 plus 0 would be 2. So it's going to be a little bit steeper. All right, what about this one? 1 plus 0? 1. So kind of the same as this guy. Now this one is 1 plus 1, which is 2. And this one is 2 plus 1, which is 3. So it should be kind of, you're getting steeper and steeper. Now this one up here, 2 plus 0 would be 2. So a little bit steeper than the 1. Then this one is 2 plus 1. Steeper than that. And then this one, 2 plus 2, is going to be the steepest of all. So you even can kind of see the little curvy shape that's happening. And then I guess let's do this stuff. So 2 plus -1 is 1. And then this one, 2 and -1, that's also going to be 1. Once again, it doesn't have to be perfect. Make sure you don't contradict yourself, but that mainly comes into effect with zeros, undefineds, negatives, positives. All right, so now we're going to do this other side here. So once again, you're just adding up x and y. So here, -2 plus 1 is going to be -1. So if you were to draw this line as a positive, you'd lose points because that should be negative. So your little tick mark should go as a negative slope. Now here, -1 plus 0, also -1. -2 plus 0, -2, so a little bit steeper of a negative slope. -1 plus 0, -1. And then this one, -2 plus 1, -1. -2 plus 0, a steeper negative. -1 plus -1 is also going to be a steeper negative. So you can kind of see the pattern is you're getting steeper and steeper in the negative direction. So it kind of goes whoosh, like that.
So is it like a diagonal tangent line then?
Mm-hmm. It's got like a, it probably has a, not a tangent line, but a slant asymptote. Yes. So that's probably what's going on here is you have some kind of slant asymptote.
Not tangent, I don't know why I said tangent line.
I knew what you meant. All right. So on the AP test, sometimes on the free response, they will give you the little dots like that, and you will have to just sketch out your tangent line, and as long as you don't contradict yourself and you're good with your zeros and your undefined, you're going to be good to go. Make sense? Okay, the other type questions that you might see, we're not going to do 12 and 13. They're just more practicing on sketching, but you're going to have homework on that. All right, the other type questions that you're going to see is multiple choice questions. We're just matching. And on the free response, a lot of times it's going to bring back equation of a tangent line. All right, so Let f be the function that satisfies the given differential. Write the equation of the tangent line to the curve y equals, there's supposed to be an f there. F of x through the point -1, -2. What three things do you need for tangent lines? X, y, and m. What's my x value?
-1,
What's my y value?
-2.
And how do I find m?
Whatever the number is at that point.
The derivative.
I'm plugging in, yeah.
Yep, plug in your x and y into your derivative. So when I'm plugging in -1, -2 into my derivative, which that's all this notation means, dy dx at -1, -2, 1 minus -1 times -2, which is going to end up being 1 minus 2, which is -1. Is that okay? Okay, so your slope is -1. And now all we got to do is write the equation of the tangent line. Do y'all remember how to do that?
Y plus 2 equals -1 parentheses x plus 1.
So really, it had nothing to do with it.
Yep, nothing to do with the slope.
I'm sorry.
The slope field. So on the AP test, sometimes it'll be like, it'll give you a slope field, it'll give you all this information, and then part A is just like write the equation of the tangent line, which you should be able to see on the slope field, but you don't actually have to use the slope field to do it. So your tangent line is going to be going through -1, -2, which is this point right here. It's got a slope of -1. So your tangent line is going to do something like that. And your function at that point, because we have an initial condition, so at this point here, it's going to go you can kind of go along the slope field. And then you can see you kind of have a horizontal asymptote there, and along the slope field like this, and you have a horizontal asymptote there. So what I did in green is called sketching the solution, and we're going to work more with that tomorrow. But that is the other thing that I said, your other rule for slope fields is you don't cross the slope field. So as you can see with my slope field on that green line, you can touch your little tick marks. But what you don't want to do, and this is where you lose points, is if you have this point here and you were to like cross it like this. So do you see all of those that I crossed? That's bad. So that would give you points off. So as long as you go with the flow, it doesn't have to, everybody's isn't going to be exact because you're kind of just going with the flow of it. But as long as you go with the flow, you won't get points counted off. And we'll practice more with that tomorrow. But you can kind of see that that is your equation. The blue line is your equation of the tangent line. So you can kind of see it happening on the graph. But to come up with the equation, you did not need the graph. Okay? So on this one, 15, it says, below is the slope field for which of the following differential equations? So when you come across these questions, these multiple choice questions, it's kind of like an elimination type strategy. Right? You're going to just start eliminating the ones that don't work. So when I come across these, the first thing I look at is I look at my slope field and I ask myself, do I have some kind of vertical or horizontal pattern? Because if you have these same slopes happening vertically, that means that the y doesn't matter. Because it's only the x that's affecting those slopes. Now, do I have the same slopes happening vertically?
No.
No. What about horizontally?
No.
No. So since my slopes aren't the same vertically or horizontally, so you see your slopes are changing as you're going across, that means that my slope, my differential, is going to have x and y. All right, so if there is a horizontal pattern, you are only going to have y. If you have a vertical pattern, your differential will only have x. In my case, there's no pattern, horizontally or vertically, so that means I have to have both. All right, so no pattern means your differential is going to have both x and y. Does that make sense?
Yes.
Okay, so from my answer choices, because I know that it's going to have both x and y, I can eliminate. It's not going to be A, B, or E. Because those are all specifically in terms of one variable. So automatically just knowing the pattern thing, you've got a 50-50 shot now of getting it right. And then from here, you just kind of guess and check. You just like pick some points and see which one works. I think it is helpful if you look for when your slope is 0. So you can kind of see right here that you have the 0 slope diagonally. Just kind of see what I highlighted there. Okay, so kind of look for when your slope is 0, look for when it's undefined. Those are kind of like your key slopes. So my slope is going to be 0 at 1, -1. So which one of these works for giving you a slope of 0 at 1, -1?
C.
C. So C is your answer, not D. So once you narrow it down, just start picking points and see which one works. All right, so just as a reminder, the slope field is created by using the differential or the derivative. All right, so you plug in to the derivative. The slope field creates the graph of y or f of x, the general solution. So it creates the graph of the general form. All right, so down here we have this matching. So what I mean is, what kind of equation does number 1 look like? Like if you were to draw a quadratic, right? So it looks like a quadratic. It is not C though, because these are the derivative. Does that make sense? So the derivative gives you the slopes, but it doesn't create the graph. It creates the graph of y, regular y, like the integral. All right, so let's kind of just start with A. So which slope is going to give you slopes of 1?
7.
Wait, which one?
7.
A slope is 1. Like your little tick marks have a slope of 1. 3. Which one would 7 be? Which letter?
I.
I. Because slope would be 0. Does that make sense?
Yeah.
All right, so I did 3, and we did 7. All right, so let's look at another easy one. So look at number 10. If you notice, we don't have any tick marks over here in the negative spot. So which differential is that going to be?
H.
H. Because why?
Because it can't be negative.
Because you can't be negative, because you can't square root a negative number. Okay, so let's look at cosine and sine now. So cosine and sine, you can narrow down to which two?
That was 2 and 5.
2 and 5, yep. So cosine and sine, I know one's going to be 2, one's going to be 5. Now, do you remember, back from pre-cal, is sine going to go through the 0, through the origin, or is it going to start at the top? Do y'all remember?
Sine is through.
Sine is through the origin, cosine makes the bowl shape at the top. So sine makes, the way I remember it, sine makes the S sine, cosine makes the bowl. Does that make sense? So sine is going to start at the origin, cosine is going to start at the top. All right, but remember, this guy here isn't the graph of my slope field, it gives me my slope field. Because this is going to give you the graph of the integral, right? What's the integral of cosine? Sine. So which one, 2 or 5, looks like sine?
2.
2. So this one would be 2. Does that make sense? Because the derivative shouldn't match up with your slope field. Like those shouldn't be the same exact functions. You have to think about the integral, which means that g is going to be
5.
5, because the integral of negative sine would be cosine. All right, so now I took care of 2, and I took care of 5. All right, so let's see what else I got going on. All right, let's look at 2x. All right, so when you plug in positive numbers, what's your slope going to be? Positive. So over here on the right side, I should have positive slopes. When you plug in negative numbers, what should your slope be?
Negative.
Negative slopes. And when you plug in 0, what is your slope? 0. So I should have horizontal slopes there. So which graph looks like that?
1.
1. Oops. All right, so that takes care of 1. Now on C, when you plug in positive numbers, what's your slope?
Positive.
Positive. When you plug in negative numbers, what's your slope?
Positive.
Positive. And when you plug in 0, what's your slope?
0.
0. So at 0, I should have 0. So which one looks like that?
4.
Which one?
4.
Mm,
Oh, wait, sorry, I don't know what I was looking at.
So the problem with 4 is that at 0, it's not horizontal. Which one? 8, yes.
Oh,
So
those
this
straight up and
one,
down.
what?
Oh, those lines look straight up and down. I thought that was something different. Like, you see what I'm saying? Like how they're like straight up.
These
like
guys?
this. Yeah.
Yes, they do look really straight up and down, so it looks like, but they're just really steep slopes. And so what this graph is it's the cubic.
Mhm.
And so just as you're getting really far this way, it's just really, really
Yeah.
steep. And if you think about the integral of 3x squared, what's the integral of 3x squared?
X cubed.
X cubed. That one always tricks people up because of those really straight vertical lines. Okay, on D. When you plug in 0, what are you getting for your slope? Undefined. So where do you have a vertical or an undefined slope at 0? 4. Because these guys right here, they're vertical at 0. And you can kind of see the shape goes whoop, like that, where you get those, that asymptote. All right, so which ones are we down to? So we used 4, we used 8,
6 and 9.
6 and 9. All right, what's the integral of e to the x? E to the x. So e to the x is the only one where the slope field will be the same thing as the derivative, which is the same thing as the integral, because e to the x is e to the x. Which is which one?
8.
What? 6.
6. We already used 8. 8 was the
Yeah.
cubic one.
Right across a lot.
So e to the x looks like that, with the asymptote like that. And that leaves me with j, which is going to be 9. What's the integral of secant squared?
Tangent.
Tangent. Y'all remember what tangent x looks like?
Yes.
It's got all the asymptotes, and in between it's got the cubics, which is kind of what number 9 looks like. Okay, so that's all I'm doing today. On your homework, let me help you on, I'm gonna just help you with the circle, because people saw the circle and then lost it. On this circle 1, I've got almost vertical lines right here when when y is 0. So when y is 0, my slope is basically undefined. Do y'all see that on the circle? And then when x is 0, my slope is 0. All right, so now look at your differentials. Which one would give you a slope of 0 when x is 0, but a slope of undefined when y is 0? 10. So it helps when you kind of look for those key points. Where are you undefined? Where are you 0? Kind of eliminate. Look for some patterns. So like on B, do you see how on B I have this vertical pattern happen in here? Like those slopes are all the same going across.
It's a y, right?
So the only thing that's affecting this slope is y.
So
So-
it'd be 9 or 8.
8. you would be between 8 and 9, but on that one, positive is positive, negative is negative, so you're multiplying.
I just thought the number was 9. I thought it went like 5.
Gotcha, yeah. So it's kind of like that, you just kind of have to look for the patterns. There's not really another way to do it. But we are going to be working with slope fields a little bit more for the rest of the week. And like I said, on the free response, it's either sketching a slope field, or you'll have to draw the solution, or it's a multiple choice question and you're just matching. And that's it. Tomorrow we'll be in here. 4th period is getting displaced, but we're still doing stuff. So.